Okay, so another series of explanation. All right, so this says the group two elements share common chemical properties. Okay, calcium reacts in cold water more quickly than magnesium because more energy is required to remove the outer electrons in magnesium. Okay, this occurs even though high calcium atoms have greater nuclear charge. Okay, nuclear charge is actually number of proton. Don't please don't get confused. So nuclear charge is basically number of proton. Okay, so if I have this data, for example, 13Al27. So 13 is actually number of proton. Okay, so don't get confused. So the number of proton is always the same as the number of electron. Okay, so actually 13. All right. So energy, why more energy? More energy required to remove outer cell in magnesium than in calcium. Yeah, of course, if you see here, magnesium is 12, okay, and then calcium is 20. All right, so the proton number of magnesium is 12, the proton number of calcium is 20. So calcium has less number of shell. All right, so because you have only one S2, two S2, two P6, and three S2. So while this one, for calcium, you have one S2, two S2, two P6, three S2, three P6. All right, so this is already 18, and then four S2. So it means that calcium has extra shell compared to magnesium. So whenever you have less number of shell, then it will increase the bonding between the electron in the outer cell or valence electron with nucleus. So when the bonding, okay, when bonding between valence electron and nucleus is very high, then it needs energy, or it will have more energy, or it will have more ionization energy, because ionization energy basically energy needed to remove one electron from the outer cell. If the bonding between the electron and the nucleus is very strong, okay, it's very strong, then it's not easy to remove this electron. As a result, it will give you higher melting point, oh sorry, higher ionization energy. Okay, so that's why it requires more energy here. So to answer this question, so we can say that here, because magnesium has less shell, okay, or shielding effect. All right, and then because yeah, as I mentioned to you earlier, because it has smaller distance. Okay, so smaller distance. So magnesium has less shell compared to calcium. Calcium, you have more shells. Okay, next is actually this one. You have a strontium react with cold water. Okay, so very easy. So it's actually strontium is actually solid because it is in group 2, and then it reacts with water, cold water. Please don't forget to put L, okay, liquid. So, and then it will give you strontium hydroxide and hydrogen gas. Okay, so this one is aqueous. Okay, so how do I know strontium hydroxide given as SrOH2? Because Sr is in group 2, so it will have +2 charge, and OH is actually -1. You move this number diagonally, then you'll have this form of SrOH2. Don't forget to write the state symbol as well. All right. So next is I have the same amount mole of calcium, all right, and then strontium, and then I have two beakers. So this one is actually calcium, and the other one is strontium. They have the same mole, all right, and then we have 100 cm cube of cold water on both beaker. At the end of each reaction, a white solid and colorless solution are seen in both beakers. Predict which element, calcium or strontium, produces more alkaline solution. So please be reminded that if you see periodic table, remember, yeah, down the group, the reactivity of metal towards water increases. It means that strontium is more reactive, okay, or more readily to react with water to give strontium hydroxide. Okay, so that's why the answer is actually strontium. Okay, because it form more soluble. So it's actually it will. Okay, so this one is more soluble because of more soluble. Okay, because it's actually more soluble. And then SrOH2 is also stronger. Okay, so it's actually easily dissociated. Okay, all right. Why? Because basically size of Mg, so size of CS like this, size of Sr even bigger. So if you have a so for example, you have a here you have a ions of Sr, and then size of OH is smaller. Okay, so as you know, as we move down the group, number of proton increases, number of electron increases, also number of shell also increases. So it makes the size of CSR is bigger or larger than size of Ca. So whenever you have a different or discrepancy in terms of radius, it means that Sr and OH is less attracted. It means that they have a weaker bonding compared to Ca. Therefore, when you add to water, it's very easy for molecule of water to hydrated this Sr and OH. Okay, all right. So it's very easy for the molecule of water. Okay, so there will be like ion and dipole bonding. Okay, so it's like that. That's why, because the size of Sr and OH are different, meaning Sr is more larger than OH, and then it makes the bonding between Sr and OH is weaker. Then when you add to water, it's very easy for water to establish this dipole negative and ion positive of Sr bonding. So when you have a dipole negative and ion bonding, then very easy to split them away. Okay, so that's why it produces more alkaline solution. So as a consequence of this, it means that if we calculate the pH, or if we determine the pH of SrOH2 compared to CaOH2, pH SrOH2 is higher than pH of CaOH2, because SrOH2 is more readily to split or to give away or to liberated OH minus. Okay, as you know, the strength, the more or the stronger the base, the easier to dismiss OH minus. All right. Next is maybe one more. Okay, describe one observation when magnesium carbonate is added to uh, excess sulfuric acid. So we will have magnesium carbonate. All right. So magnesium carbonate, okay, plus H2SO4. All right, so it will give me, so it's actually plus 2 minus 2. This one is plus 1 and the other one is minus 2. So what I need to do is actually I put them together. Okay, this one together and the other one is actually together. Okay, H and CO3. Okay, so whenever you have carbonate, always remember that you have a CO2 and water. So the product is actually MgSO4, because Mg plus 2 SO4, 2 minus, when you move diagonally, you'll have MgSO4, 2, 2, but then we have to use the simplest ratio, then you'll have MgSO4 only, all right? So plus H2O plus CO2. Always remember, when you have a carbonate, then you have also H2O and CO2. Okay, because it says that you only need to find or to describe one observation. So you may say that this one is actually effervescence. Effervescence. Okay, or you may say that yeah, we have a vis of CO2. Okay. All right, so I hope it helps you to understand these questions. Thank you for watching.